Walk y'all through the astronomy test in jsFun. I've got it loaded into a REPL here, just copied and pasted from the text editor. Roughly the format that you'll be doing these tests in mid-mods or final assessments. Basically, we've got our data sets above and then our tests here, just so that it's easy to follow what I'm doing. I've also got the data sets in a tab here, so I'll just skip between the two when I need to, instead of scrolling up and down. So REPL problems, you'll get a few of those. Reloaded. Okay. Basically, in our first test, it looks like we're looking to return an array of all of the stars that appear in any constellations listed in the constellations object. So I'm reading that first off just to get familiar with roughly what we're looking for, but I should probably spend some more time looking at the actual data sets before I pseudocode. What methods we use to access this information are going to be determined by how it's actually structured. So we should see how our data looks. Basically, we've got a constellations object full of key value pairs, properties basically that represent objects themselves, and then stars, which is an array of objects. We know that because stars is an array, we'll be able to use a prototype method to iterate through. On the other hand, constellations will actually have to know the names of the keys of each of these because we can't iterate through. We have to access them via bracket notation using these specific names. So that tells us a little bit about what we're going to do. And if I recall, we were looking for these star names, figuring out which star arrays they exist in. So I know that I'm going to have to, like I said, access each key, then get into the value, which is an object, get into the stars, access the stars key, and then the array value of that star's property. So let's do some pseudocoding. That'll make it all a little more clear cut. I really do think the more thorough your pseudocode instructions, the less trouble you'll have solving the problem. I like to be so detailed that I'm basically just following my own instructions, and so it's way easier to stay on track, especially when you inevitably do sort of hit a wall where you're not getting what you think and you need to do some console logging to not lose your place. So to start, I know that I first need to know the names of these stars before I cross-reference them in the constellations object. So let's say we're going to iterate through the stars array and access each star is what we're going to call the element, each one, as we iterate through. As we access each star, we'll put our next instructions on the next line. I like to note what method I'm going to be using, so I don't lose track of that either. I'm going to use reduce. I think that'll be the easiest way to do this. It really is. Once you get comfortable with reduce, it kind of replaces for each. Initially, when I solved this, I saw my early solution. It was using nested for each loops, which works. And if you're more comfortable sort of compartmentalizing it with several for each loops, that's totally fine. At this point, I can just write cleaner code using reduce, so I'm going to do that. So I'm going to iterate through with my reduce method. We know that when you declare a reduce method, or I should say when you chain it on and initialize it, you have two parameters, your accumulator and then your individual element name. So we're going to have to initialize accumulator as an empty array because that's our output. It's two objects inside of an array is what we're looking for. So my accumulator most often when we're using reduce is going to represent whatever data type our final output should be. So initialize accumulator as empty array so that we can push our results into it. once we find matches, stars that match. And I'll just note that. Good to keep track of your input and output. Then I know that as I'm accessing each star, I need to cross-reference it, like I said, with the contents of the stars property of each object within the constellations object. So we need to get the names of all of these keys. We're going to use object.keys. So I'll say assign keys in constellation dataset to new key names is what we'll name it, array, using object.keys. Now that we have our key names, we want to iterate through, right? Iterate key names, and for each name, I'm saying for each name, not the actual method. That's just kind of what's happening using our reduce method. For each name, run our conditional to check if it has the current star name. And actually, yeah, we are going to want to use a for each within the reduce. I misspoke. Okay. So as we iterate through each key name within our reduce function that's going through each star, we need to check one against the other. So our conditional, say in our conditional, access the constellation element with that key name. Meaning, we'll tap into our constellations array, use bracket notation since this is a dynamic key name, it'll change through each iteration. We're going to do constellations and then name, because that's the placeholder we gave to each key name as we iterate through. We're going to check whether it includes that star name. So we'll skip to our next step and say check if its stars property, which is an array, its value, includes, hint there, the current star being like the one we're on in each iteration with reduce, the current star's name, which should be a string, using includes. Okay? So if we do find a match, if it includes, if the stars array of a constellation includes a given star's name, then what do we want to do? We want to push it into our accumulator. That's why we made an empty array. That's why we're using reduce. So we'll say if truthy, push current star element into accumulator. Okay. And then finally, got to remember that return. We'll return our accumulator, and that'll give us our final value. Okay, so that was a bit long-winded. I probably wouldn't talk that much during an actual test, but I want you to understand how to solve it, since I'm not just, quickly running through it to an instructor. But that's basically, I would probably be, if not that thorough, close to it, pseudocoding during an assessment. So we can jump into it. Just because I like to kind of wrap my functionality in one function expression, I'm going to do it that way. You don't have to. You could just, each one of these methods could be out on its own, so long as you, in the end, get the result you're looking for. I'm going to wrap them into one. We'll call it stars in constellations, since that's the same function expression name they used in jsFun. So we'll say, we know we want to iterate through our stars array, so we'll do stars.reduce. Our accumulator, we could call whatever we want. You're supposed to be specific. I'm just going to call it, in this case, new array, since we're already going to, have stars and constellations as a more specific name as the function expression. Each individual element represents a star. Now that we've built our syntax there, we should initialize our accumulator as well. Put that right here between the curly and paren. So just empty array. And right away, I'm going to remember to do my return. We'll just say return, and it's called new array. Okay. So we have our structure here. I might even, right off the bat, do my console log, which will give us our result in the console here when we're done. And we'll clear that. So, first things first, we said that we need to get the key names, right? So, let's call it key names. And we decided we're going to use object.keys. And what are we getting the keys of? It's our constellations object. So it's just object.keys. You put the name of the object in the parentheses. We've got our key names. We're already iterating through stars and getting each individual star name. Now we can cross-reference the two. We'll do that by iterating through those key names. And for each name, we'll run our conditional. And why am I doing for each, not a more specific proprietary prototype method? Well, because we don't actually want to return anything. We already have our accumulator. We're just going to push into it. So for each is going to be nice and generic for us. So we'll do our if conditional. And we're checking if that constellation key value pair with that key name includes that star, right? So how do we access that? With bracket notation, we're going to do if constellations with our name. So we do this with each key name. So that taps us into each constellation element, and then how do we get to its stars or its names? .names, .stars. So for each constellation, access its stars, key value pair, and then check, since it's an array, the value. Check if it includes. And what are we looking for? The name of the star, right? Our outer layer, which, how do we get to that? We're iterating through, getting to each one of these objects. Each one of these represents a star, so it's going to be star.name to check for it. So stars.includes star.name. Okay, so what do we do if we actually have a match? That's what our accumulator's for. We'll push that star name in, new array.push, and we're looking for the entire star object, right? They told us what output we were looking for. It wasn't just the name Regal or Betelgeuse, Beetlejuice. Let's go with Beetlejuice, great movie. It's looking for the entire object. So we're pushing in the whole star. Good to go. We should be able to run it, and as long as we get these two objects within our array, we know it worked. There it is, Regal and Beetlejuice. Okay, number 1 down. Number 2, we are looking to return an object with keys of the different colors of the stars, whose values are arrays containing the star objects that match. Okay, so our output is an object. The object is full of key value pair properties, one for each color. So that's important to note. We want to make sure there are no repeats. We're going to access each color once, create that key value pair within the object, and probably give it an empty array as a value so that we can then push in objects as we identify those objects that, you know, satisfy that color requirement. So let's see. I think I'm going to iterate through the stars array and access each star element. And then I believe it's just a color property. So it's just going to be that star.color, right? So each star element's color property. And because once again we're going to be creating these key value pairs and then pushing in individual objects, this sounds like a good situation to be using reduce, so we can accumulate these. So let's say reduce, then once again I'm going to remember to initialize my accumulator right away, and this time it's going to be an empty object, right? Because that's our return data type. Our output. Then we want, as we access each star, we're going to want to use a conditional to check. We know starting out that this is just an empty object, right, on the first iteration, but in future iterations we may have already created our key value pairs. You know, on the second pass, blue might already exist. If so, we don't want to create a second blue property. So we're checking if it exists, and if not, we'll make it. So how should we phrase that? Use conditional to check if our accumulator object, it's an empty object, contains a key name of that star.color. Because again, we're iterating through, we're accessing each star at this point using reduce. Okay. So if it exists, we'll move on, but if not, add it with an empty array as value. So again, starting with an empty array, none of this exists. First pass, it'll then create blue and it'll assign it empty array as value so that we can then push in objects on future passes. So then we want to do that, set up the functionality to push objects into the color they belong in. So let's say after conditional, push that star element into that accumulator color array. Again, this represents accumulator is our empty object, bracket notation to dynamically access whatever color name. So that represents blue, white, yellow, orange, or red. And it's going to be an array. That's our value. So after we do that, we should just be able to return it. This is definitely one that looks more complicated than it is. It just helps to be thorough pseudocoding it, because I don't think it's going to be very much code to actually get it done. Okay, so once again, I'm going to wrap this in a function expression. In jsFun, it was stars by color. Let's go with that. We're going to iterate through our stars array. So stars dot, we decided reduce. We got our accumulator. Each element is a star. Arrow function. And conditional. After we initialize, of course. Empty object. And return. Okay, now we can do our conditional. Let's do an if statement, and again we're checking if our accumulator has a key name of that star.color yet. We know it doesn't on the first pass, but in the future it might exist. So if accumulator of that star.color key doesn't exist, then we create it. Looks a little redundant, but that's, I think, the best way to do it. If accumulator star.color doesn't exist, make it exist. Assigning a value of empty array. Okay. So that should create all of our colors. If we ran this right now, we would probably just have blue, white, through red, but all with empty arrays as values. So now we have to put in the appropriate objects. So once again, accumulator of star.color with that name as the key, .push, and put that star in. And that should push all of our objects into the appropriate color name. Okay, so we'll console log our function expression. And I think I got everything. We'll comment out our previous one so it's clear in the console here. And we got an error. Naming issue, stars by color. There it is. Obviously, this is just the shorthand right here. Our console is actually going to spell it out. But to double check that we got the right output, it is an object. We have a key of blue. We have a value of an array. Within the array is a bunch of objects that represent the stars of that color. And sure enough, each star has the right color here. I'm not going to comb through all of these, but blue, white, yellow, orange, red, no repeats. Looks good to me. All right, on to the third test. Get rid of that console log, clear the console. And in this case, we are looking to return an array of the names of the constellations that the brightest stars are part of. E.g., and we have a list of what look to be strings within an array. Okay, straightforward enough, pretty simple output. But how are we going to do this? I think it's phrased a little confusingly, but looking at how I did it, they're looking for, there's no cutoff for like how bright the stars are. It's all of them. It's just sorting them from least bright to brightest is important to note. So if we're looking at our stars array, it already is almost in order. Visual magnitude is the property we're looking at for brightness, going from negative 1.46 all the way up to 0.61. But again, this is a good chance not to race into the code, because even though it looks like it might already be in order. If you look closely, there are a couple that would be flip-flopped if we didn't bother sorting them. Let's see, where is it? Here we go. Capella in the constellation Auriga, visual magnitude 0.08. That should be higher on the list if we're going from least to greatest. These two should flip spots. Also worth noting, we're going to be returning the constellation names, right? So like Carina, Canis Major. This one's an empty string. I didn't see an empty string in our output here, so we're going to need to build in functionality to exclude that. So I think we get the idea. I'm going to start writing my pseudo. I know that I need to sort right away. Might as well get everything in the right order first before we return anything. So I'm going to sort my stars array from lowest visual magnitude to highest visual magnitude using sort, of course. Once we have our stars sorted, we want to iterate through those, and we will have produced a new array, right? When you sort, you return a new array. So we'll call that ordered stars. So iterate through ordered stars array, which we got from that sort method. And when we iterate through, what are we going to do? Well, we're going to be pushing into another array. We could use nested for each loops. I'm just going to use reduce yet again. Why not? We're getting comfortable with it. So we want to initialize right away again. We're looking for an empty array as the output, just like the first test. And once we're inside, we want to access each star element, each one of these, right? And we're just trying to pick out of it its constellation name, so long as that constellation is truthy, because an empty string would be falsy. So all we need to do is check that each star.constellation is truthy. If so, we'll push it into our accumulator array. Okay, so I'm going to say for each star element, don't need to use for each. That's just what reduce is doing for us. Check if its constellation property is truthy. We'll say to eliminate empty string values, just to get rid of that one. If truthy, push star.constellation into accumulator array, and last, of course, we return our accumulator. All right, so we know what we need to do. Let's go ahead and do it. Hold on. Okay. Once again, I'm going to do a function expression. Call it ordered stars. Or actually, you know what? Let's just do the sort out on its own, and then the rest will be its own function expression. So ordered stars is just to do our sort stars dot sort a dash b. All we do is return by visual magnitude, right? And we want to do least to greatest to keep them in order. A dot visual magnitude to B dot visual magnitude to flip-flop those couple elements that weren't in order in our array. Now I'm going to do my function expression. We'll call it bright constellations. We're going to use reduce, like we said, to go through our ordered stars. Set our accumulator. Each element is a star, so we'll call it that. Then we want to do our conditional. We said for each star element. We're already iterating through using reduce, so now we can go straight to the conditional. If its constellation property is truthy, we'll push it into the accumulator. So if star dot constellation, right? Because if it's truthy, we can just say basically if it exists, then our accumulator, which I forgot to do, is right here, empty array. Then we push into it that star constellation name. Get our return, and that should be it. We should be able to console log our function expression, and let's see what happens. There it is. Looks right to me. We excluded the empty string. These other stars that were slightly out of order are in order. So there you have it. That's the astronomy test. I would say that not explaining it quite so in depth, that in total should not take more than like 20 minutes or so. So if you can do that, you're in really good shape for the mid-mods and the final. I'd say this is maybe a step or two above what I had personally and what it sounds like most of the mid-mods and assessments are like. But I'd say if you can do this well, if you really understand how to cross-reference two different data sets, one being an array, one being an object, you're really in really good shape. So hope that helps. Good luck, everyone.